Hi guys, today I wanted to talk to you about a project that I recently made. It's a Flycutter. This project was on my to-do list for quite some time, but I never really got around to do it. But I saw some videos recently on YouTube of people doing one, building one, and actually had some work coming up where I needed a larger diameter Flycutter to deck off some aluminum parts. And I thought, well, that would be a good time to start to do this project. It's a neat little project. You can do it in several hours. It's no big deal. I mean, you need a lathe and a milling machine to do all the finishing, especially because of the angle. But other than that, there are no special tools needed. As you can see here, it has a around 20 millimeter shank to clamp it in a ER32 collet. Diameter is roughly around 50 millimeter because that's what I had left. It's some part of steel, I don't know what, just out of the parts, scrap parts bin. I don't know what material it is, but it's really tough steel. But honestly, I think you can get away with any steel you want because the cutting forces are relatively low. I will mount as a tool to spin clockwise in the machine because all my other tools are spinning clockwise as well, so I didn't want to switch during operations because it's bound to bring some errors there if you accidentally turn on the like a shelf mill in the wrong direction. Don't ask me how I know that, but well, as you can see. I made it for an indexable tool holder because that's what I use most of the time. I hardly use high-speed steel anymore, but you can do it also for 12 millimeter high-speed steel shafts or whatever size you like. Shank is around 30 millimeters long. Head is around, it was 50 millimeter raster, so I just tune it down a little bit to make it look nice. I quickly wanted to talk to you about the insertable tooling. As you can see, I made this one for a 12 millimeter sized inserts. It's a SCLCL 1212H09. And I choose this one because it has the H09 has a very relatively large insert. We use the same insert as on the 16 millimeter shaft size, shank size, and you can see that one, even if it's much slimmer, it has the same insert. And actually, I wanted to use that one first because I had that one lying around. But once I finished the head and I took some measurements, I think it probably would have fit, but I think it's too big and bulky to put that one in there. So you can do that, but I kind of like the 12 millimeter size better. It's a better fit, I think. As you can see here, these are the tools that I previously used for decking off larger parts. This is a 40 millimeter shell mill with indexable inserts. It has 4 inserts in there also. These are highly polished aluminum inserts. And unfortunately, they're not cheap. I've heard one insert is going about, I think it's around 15 euros. So if you break them, it's a costly experience. What some people do, and I also tried it, but I wasn't really happy with it myself, probably because the inserts are not made for this. You can also use a shell mill and just add one insert for light decking off parts. It's possible to do, but as you can see, even that there's a 50 millimeter head, you only get around like 30-35 millimeter of actual usable diameter for decking off. So a Flycutter, even if you build a really small one, is always a much better choice, and you get a much larger diameter. If you can see here that even if in this I mounted it like it's around, I don't know, 110, 105 millimeter diameter, and you can even go higher. That's not a problem. Let's talk about work holding for a minute. The last one I made, I used a 5C collar chuck in this rectangular block. So basically you clamp the block in the vise and then you can twist the angle like this. Unfortunately, it slipped at some point, so I really have to tighten it up to do some heavier cuts. This time I think we will clamp it in the vise. I mean, a V-block probably would be better, but I will keep the cutting forces low, so it's not a big issue. There are probably several ways to set it at the right angle. As I said, 10 degree would be optimal. What you can do is, if you don't have an angle finder, you can use like a ruler like that one. Use the head as a perpendicular surface, and then you can just aim like this and set it at 10 degrees. These things are not terribly accurate, as you can see. It's always fluctuating around 10, but I call that good enough. As you can see, I experimented with different feed rates and cutting depth, but the last cut was pretty aggressive, so I will probably turn down it a little bit. I heard some light chattering because the setup isn't that rigid here, but so far I'm pretty happy, and it's a better result than the 5C collar, at least in this case. The only advantage for me for the 5C collar was that I only had to flip it around 90 degrees to get a registered angle for drill and tapping the holes, and in this case I just have to measure it. But it's no big deal. All the other features like milling the slots and the relief for the threads that coming in from this side will do on this milling machine, so I don't have to measure anything. I just keep it here in the vise, and then everything will be fine. Okay, until now all the steps for building a clockwise or counterclockwise Flycutter would have been the same, but now you have to decide which one you actually want to build. As I said before, I want to have a clockwise spinning Flycutter, so in my case you see, if I hold this head right here, the insert or the cut for the insert has to be on my side of the center line. If you want to do it the other way around, you have to basically mill it like this. That's the only thing you have to worry about. And keep in mind that I flipped the part to the right side, so it's a 10 degree angle in this direction. If you do it the other way, you also have to think about it. Then the cutting for the insert also have to be mirrored. So really take a look at that before you're doing it. So as you can see, I blued up the surface, or in my case, redded up the surface, I guess, for better visibility. And what I used here is a neat little tool to find the center point. Just do two small scribe lines, and you can see where the center point is. And from there, I just basically made a parallel line to mark the center line. This just gives me an indication how far I can go to reach the center, and then I will just mill from there 12 millimeters in my direction. That's all there is to it. Then you have to do the second cut here. This is just basically an optical thing, and it gives you better access to later do the threading and the holes in the threading for the screws to hold the insert in place. But it's not a critical dimension. Some cooling probably would be nice and help out a lot for the surface finish here, but this machine is not rigged up for cooling, and also it makes a hell of a mess here, so I am just going to do it dry. As you maybe saw, I kept slightly away from the center line to be able to make one final pass in full depth to get a nice and even surface finish on the sides of the slot. Now I'm gonna do the other side of the slot, and I'm also going full depth and just going slowly to the 12mm point that I need. In this type of machine, you're removing the whole head for the y-axis. It's a little bit tricky, at least for me, to get it really exactly positioned at the 100th mark that I wanted to go further towards me. A DRO probably would be nice here, but I'm looking into that, and maybe I will add one further. As you can see here, it's a little bit of, but that's a quite good fit, I think. As you can see, I now started to mill the relief slot in the back where the screws are coming in to hold the insert holder, and I'm just going in here full depth and doing several passes. Basically I'm feeding manually because it's easier for me. I can stand on this side of the machine and do the feed with one hand and moving the head with the other hand, and I just will do the last path with the automatic feed rate to get a nicer surface finish. I'm trying to have this part also 12mm in width, so it looks a little bit more symmetrical to the slot that I milled, but that's just an optical thing. You can basically, as once as you have a flat surface here that is wide enough for the 3 through screws, you can basically stop. All the rest is just optics. Here you can see the finished head. Now all that is missing is drill and tap the 3 holes, and then we're done. As you can see, I made it slightly larger shank, basically because the material was there and I didn't want to throw it away. I can always shorten the shank, but there's one thing I realized while making this one. As you can see, if you use an ER32 collet, you can't use it flush, because at least in my case, the wrench I'm using needs some clearance here and actually to engage. So you actually have to basically give it like 1 centimeter or so to get in there and tighten the wrench properly. Yeah, probably 5 or 6mm will also be enough. But if you make the shaft too short, you're actually limiting yourself here and might have a problem. I think there are some wrenches out there that only using like a half key, and you can come in from the side, but I don't have one. Now basically all that's left is drill and tap the holes. I think I misspoke earlier, I said M5, but I'm actually using M6 grub screws, and I got really beefy ones, so that the thread engagement is relatively large, because we have almost 12mm of material, so I'm trying to get a larger grub screw here. Yeah, I'm drilling 5mm and then just do the thread manually on the machine while it's in there and positioned. Now we're back at the drill press. Basically all I did was make sure to that the groove we just milled is parallel to the white jaw. So in order that we drill the holes, so they are all parallel. I set it up like this, that I can drill all holes in one line. So basically the 10-degree angle, you can see that it's angled like that. I have in the white jaw here is some light V-groove, so I can just clamp it in there. It's not totally rigid, but I'm just doing a drilling operation, so that's not a problem here. The holes are spaced 10 millimeters apart. Now I'm done drilling the holes. I'm just going to burr it off camera and then we will meet back at the bench. Here you can see the Flycutters side by side. They're basically identical except for the shaft length and missing Mars on the new one. I cleaned it up and deburred it and I think it came out quite nicely. One thing I never tried before, but I might do for this one is like cold brewing it. So if you have any ideas on how to do that and maybe a tutorial, just add it in the comments, please. I would really appreciate that. Thank you. So now I'm going to show you some cutting videos. I wanted to show you some results from the test cut. This one here is done with a 300 millimeter per minute surface speed. And you can see that there are some slight scratches in. I mean, it's not terrible, but you can see some scratches. Then I lowered the rate down to 200 and this improved the surface finish significantly. I don't know if you can see that probably on camera, but it's really you can't feel any scratches or anything. So it's a really nice finish. It's not perfect, but it's way good enough for the things I plan to do.